All right, guys, Mr. Alent here to look at part 2 for our 10-1 notes. We started looking at trigonometry. Remember, we're in Unit 10, Section 1, which matches from the textbook Chapter 13, Section 1. We talked about trig. We brought back some old stuff, if you remember SOHCAHTOA. We talked about special right triangles, and now we're about to apply those things we talked about. And so first, it says here, use a trigonometric function to find the value of x. But notice it's a 60 degree with a 90. So this is a 30, 60, 90. So I'm actually going to show you both ways. I'm going to show you why they're actually the same, to use trig or to use the rules. Whichever one you think is easier, go for it. I don't really care as long as you get to the right conclusion. All right, so if I were applying my special right triangle rules, which I'm going to bring those back over here for a second. Right, it says right here for a 30, 60, 90 that we're at this ratio. The side lengths are at a ratio of 1 to radical 3 to 2. And again, this is the short leg of the triangle. This is the long leg, and that's the hypotenuse. Okay? And so notice here what we're looking at with the 60. This is the hypotenuse. This guy over here would be the long leg. Right, because it's opposite the 60, so it's long, and you can see it definitely looks longer than that other side. So long to hypotenuse. Now, if you remember back in geometry, we used a lot of proportions. We would set up proportions all the time, and so that's what I'm going to do right now. I'm going to set up a little proportion here. We know what the ratio should be. It should be at a ratio for long leg to hypotenuse of radical 3 to 2. So if I use that, radical 3 to 2, that ratio, that should be the same. This is what proportionality is. Same ratios. This was long leg to hypotenuse. I'm going to go long leg to hypotenuse again. X to 100. These two ratios should be the same. That's called proportionality. And now we solve for x. And what I would do to solve for x is just multiply both sides by 100 right now. We taught you something last year called cross products. But in this case, I think it's just easier to multiply by 100. So multiply by 100, so the hundreds cancel out, and you just get x equals. So you have 100 times radical 3 over 2. Well, this division of 2 would actually divide that 100 in half anyway. So you're going to get x equals 50 radical 3. It divides the 100. Okay? So that's using our special right triangles and recognizing that ratio of their sides, and we can apply it to build some proportionality. What do you do if you don't remember that? Trig, guys. So remember, with a trig, you identify your sides. There's the hypotenuse, right? So it's still hypotenuse. That obviously doesn't change. Now, instead of calling it the long leg, though, from our angle of reference, which is the 60, the x, that's the opposite leg. So it looks like I'm working with O and H, and if you remember SOHCAHTOA, O and H is so. It's sine, right? So that's why you identify first, guys. You identify because that tells you which of these we got to use, sine, cosine, or tangent. We've got a so going on here because we got O and H. So the sine of the angle theta is equal to O over H. I always like to write it out and then substitute in the information. So the sine of, now theta is always the angle. We know the angle, it's 60. Sine of 60 equals O, which is x, over h, which is 100. Okay? And now again, it's an equation we solve for x. If I multiply, to get x alone, I would go ahead and multiply both sides by 100. Right? That would cancel out the 100 over here, and I'll just have x equals 100 times the sine of 60. Now I want to show you what happens here. Two things are going to happen. These calculators that we use in class, they will simplify things as best they can, but if things get too big, they just quit simplifying. And so if I do 100 times sine 60, I'm going to get a decimal. But that's not the answer we had here, right? It doesn't look like that. And so what happened? Well, these are actually the same. If I do 5 radical 3, I'm going to get 86.6. But let me show you what happened here. The calculator knows that the sine of 60 is radical 3 over 2. But when we multiply by that 100, we got a little too big for it, and it said, I don't know what to do. Right? So if I kind of break this down in a couple of steps here, sine of 60 is radical 3 over 2, so I really have 100 times radical 3 over 2, which is exactly what we had right there. 100 times radical 3 over 2, that's going to give us that 50 radical 3. So there's two different ways to do this problem. Right, the one in purple over here, that's using the special right triangle rules, and the one in pink here is applying trig. I don't care which one you use, just use the one that you're most comfortable with. If using proportionality and ratios is good for you, then awesome. If just memorizing how to do trig and being good with that, perfect. Right? All right, problem 4. Same story. I'm going to kind of show you both methods here. This is a leg, that's the hypotenuse, right? So this is just one of the legs. It's a 45, 45, 90. So there's not like a long leg, short leg here, because for a 45, 45, these are the same length. So it's just the leg length, right? And again, back to this page. Trying to get it there. I didn't highlight it yet, but the ratio for the sides of the 45, 45, 90 are 1 to 1 to 2, where 1 and 1 are the legs, and the hypotenuse is radical 2. So if we apply proportionality like we did a moment ago, and we go leg to hypotenuse, it was leg to hypotenuse. That was the ratio, 1 to radical 2. That should be the exact same ratio as our leg to hypotenuse here, which is going to be an x to 20. Notice my consistency, right? I went leg to hypotenuse from the ratio, and I'm going leg to hypotenuse in from the triangle here. And now we again solve, and I would again multiply both sides by 20. And what I'll get is x equals 20 over radical 2, but that simplifies. Again, we don't want to leave it like that. We don't like a radical in the bottom. So what does that simplify to? Well, we can let the calculator try it. We'll see if it's going to be nice to us. We'll use the fraction. 20 over radical 2 simplifies to 10 radical 2. And there we go. Again, how that simplified is it multiplied by a radical 2 over radical 2, so that you have a 20 radical 2 over 2, because radical 2 times radical 2 is 2, and then the 2 divided into the 20 to make 10. So that was kind of what happened. So there's using special right triangles, or, right again, or use trig. So here's my angle of reference. This would be the adjacent leg. This is the hypotenuse still. So adjacent and hypotenuse, right, look back at Sobotoa. Adjacent and hypotenuse, that's a cosine. So the cosine of theta is a over h. But we know theta, it's 45. A is the x, the unknown. H is the 20. And so again, I'll multiply by 20 to solve for x, right? We're trying to get x alone, so 20's got to go. And then that'll get us x equals 20 times the cosine of 45, which is, let's see if this one can do it. 20 times cosine 45. Yeah, 10 root 2. Again, if it gave me some decimal and I wanted the radical answer, I would have just done cosine 45 and then multiplied by 20. And that's radical 2 over 2, by the way. And so then multiplying radical 2 over 2 by 20 gets you 10 radical 2. Okay, last little bit here for this first part. And we will have one more video for like our day 2 stuff, which is showing those reciprocal trig functions. But the last thing here is, for doing word problems, we often will talk about two types of angles, the angle of depression, the angle of elevation. The key about both of these is that they come directly off of this horizontal line from kind of the eyes, right? This is always about like spotting something. So like up in the airplane, spotting something on the ground, or being on the ground and spotting something up in the air. And so the way to do this is to kind of, from that line, that initial, your eyes or whatever, you create these horizontals. That's what these dashed lines are. And then this guy in between is called the line of sight, right? It's what you're seeing that object through, right? Through that line. And so from the horizontal down, that is called your angle of depression. So if you're up high looking down, angle of depression. The angle of elevation is when you're down low looking up, right? That's your angle of elevation. So angle of depression, angle of elevation there. One thing to note about them, the angle of depression is congruent to the angle of elevation. That's my little abbreviation here, angle of depression, congruent to angle of elevation. Why are they congruent? because they're alternate interior angles. If you remember from, again, your geometry days, alternate interior angles. When you have two parallel lines, like these horizontals, and a transversal coming between them, then alternate interior angles are congruent. So it's really nice then, if you're dealing with a word problem that's talking about angle of depression, angle of elevation, they're the same. So set up the triangle in the way that makes sense with the picture, but then also sometimes you can kind of swap or interchange them as needed. Okay, I got to get through these two problems here. So we have a couple of application problems. A builder is constructing, this is number 5, a wheelchair ramp from the ground to a deck with a height of 18 inches. So the deck is 18 inches tall. So we've got some deck here that's 18 inches tall, right? And some guy's building a ramp, wheelchair ramp, to it like this. So here's our, that was really not very good, but that's okay. There's our ramp. Okay, to the top of this deck. And it says the angle between the ground and the ramp must be 4.8 degrees. So this angle here, right, ramp, this is the ground, right, is 4.8 degrees. So the question is, to the nearest inch, what should be the distance d, so call it d, between the end of the ramp and the base of the deck? So what are we looking for? We're looking for this length right here. Right, end of the ramp to the base of the deck, right? If they wanted to know this length, they would just ask, what's the length of the ramp? But they didn't ask that. We want the end of the ramp. So we want to know this distance here. So there's our picture. All right, so break down the information, draw a picture. Now apply some trig. Let's see what we can do. Again, every trig problem starts the same. Identify sides. Oops, my green must be running out here. The ramp is the hypotenuse, but there's nothing there, so I'm not going to really use it. The one directly across on the 4.8, there's your opposite. The one right in next to your 4.8 is your adjacent. It looks like it's an O and A. That's a tangent, right? TOA. TOA from our SOHCAHTOA. So we're going to be using a tangent function here. So the tangent of 4.8 equals O over A. 18 over D. Now, we're going to solve using algebra, but D is on the bottom. The variable's on the bottom. So what I need to do is get D out of the bottom. How do I do that? By multiplying by D. Right, you multiply by D, because then that cancels the D out over here entirely, but now on this side, D's out of the bottom, so that's a good thing. So we've got D times the tan 4.8 equals 18, but again, we're still solving for D, so what do we got to do now? We got to divide by tan of 4.8. They are connected, the tan 4.8. They're not, you can't like separate the tan from the 4.8. They're together. They're doing their thing. Dividing those cancels out. You just have D equals 18 over the tan of 4.8, which is, I'm trying to go fast because I got to get these last problems in quick here. 18, right? So I'm just using the calculator here. 18 divided by tan 4.8. It gets me at 214.35. It said to the nearest inch. So 214.35, we would just call that 214 inches. And there you go. There's the distance, the base, or the end of the ramp to the base of the deck. All right, I've got a minute and 15 seconds to go through this last problem. A park ranger whose eye level is 5 feet above the ground measures the angle of elevation to the top of an eruption of Old Faithful geyser to be 34.6 degrees. If the ranger is standing 200 feet from the geyser's base, what is the height of the eruption to the nearest foot? All right, here's my ranger. He's 5 feet tall. He's seeing the geyser. Right, there's my geyser, right? And he sees the top of it, it says, at an angle of elevation of 34.6 degrees. Okay, so we want to know what's the total height of the eruption. Now, crikey, I'm going to have to finish this. I'm out of time. So guys, I will on the next video. So keep moving on to the next video to see me finish this problem. So we'll keep it going there.